Imagine a wind force so extreme that it can lift a 100-ton steel train straight off its tracks, strip solid asphalt off highways as if it were paper, and erase an entire suburban neighborhood in less than 60 seconds. Tornadoes are the planet's most concentrated displays of violent kinetic energy. Their internal wind speeds can breach 300 miles per hour, faster than a Formula One car at top speed. In atmospheric theory, a tornado can develop anywhere warm, humid air meets cold, dry air. We see them occasionally in the flatlands of Europe, across the tropical plains of Asia, and down in the pampas of South America. Yet, out of the roughly 1,500 tornadoes documented worldwide every single year, over 1,200 of them strike a single country. That means roughly 75% of all violent tornadoes on Earth hit less than 7% of the world's landmass. Why is the United States such an extreme weather magnet? Is it sheer geographical bad luck, or a planetary trap built by nature itself? Welcome to Inquiro. Today we decode the physics behind Tornado Alley. To understand this planetary anomaly, we must realize that ordinary rainstorms do not spawn giant tornadoes. For a true violent vortex to touch the ground, you need a rare, monstrous storm structure called a supercell. Supercells make up less than 1% of all global thunderstorms, but they are responsible for almost every devastating tornado recorded in history. A supercell requires 4 fundamental atmospheric ingredients present at the exact same moment. Ingredient number 1, moisture in the low atmosphere. Moisture acts as the high-octane fuel for the storm's warm core. Ingredient number 2, extreme atmospheric instability. Cold, heavy air must sit directly above a deep layer of warm, moist air. Because warm air is lighter, it attempts to erupt upward at immense speeds. This rapid upward eruption creates a powerful atmospheric vacuum, known as an updraft. Ingredient number 3, a lifting trigger, such as a cold front pushing underneath. This front acts as a ramp, violently forcing the warm surface air upward. But the ultimate catalyst is ingredient 4, strong wind shear. Wind shear means winds near the ground blow in one direction at low speeds, while winds high above blow much faster from an entirely different direction. This dramatic difference forces the air in between to start rolling horizontally. Think of an invisible rolling pin spinning horizontally over the landscape. When the powerful upward draft hits this spinning tube, it tilts it vertical. Suddenly, the core of the entire storm is spinning around a vertical axis. Now, these ingredients can technically happen anywhere on Earth. So why does the United States assemble all 4 conditions hundreds of times a year? The answer is written directly into the unique geology of North America. To the west, the massive Rocky Mountain range stretches completely north to south. To the south lies the tropical, scorching Gulf of Mexico. And to the far north lie the vast, frozen tundras of Canada and the Arctic. Nowhere else on Earth do these 3 climatic zones border each other so closely, with 0 mountain barriers between them running east to west. Look at Europe or Asia for comparison. Mountain ranges like the Alps or Himalayas run horizontally from west to east. These horizontal mountain walls act as giant shields, blocking frigid polar winds from directly colliding with equatorial heat. But in North America, the corridor between Canada and the Gulf is completely wide open. Warm, moist tropical air surges northward from the ocean without resistance. At the same time, Arctic air sweeps southward from Canada with nothing to stop it. These opposing air masses collide head-on over the Central Plains. States like Texas, Oklahoma, Kansas, and Nebraska form the arena known as Tornado Alley. To make matters even more volatile, dry air flows eastward over the Rocky Mountains. As this air descends off high mountain elevations, it dries out and heats up. This dry air layer slides over the humid surface air, creating an invisible atmospheric lid. Heat and humidity build up under this lid all day long like a pressure cooker. When the updraft finally punches through that lid late in the afternoon, the atmosphere literally explodes into violent supercells within minutes. Does this mean violent tornadoes never occur anywhere else in the world? Not quite. The second most frequent tornado zone is Bangladesh and eastern India. Though tornadoes are less frequent there, extreme population density makes them deadly. South America has its own tornado corridor in Argentina's Pampas, and parts of southeastern China experience devastating tornadoes during typhoons, but no region matches North America in sheer frequency, strength, and consistency. For decades, human beings were completely defenseless against these sudden monsters. In the mid-20th century, tornado warnings were virtually non-existent before touchdown. Today, meteorologists use advanced Doppler radar arrays, tracking storm rotation in real time. High-resolution satellites image the cloud tops from orbit every few seconds. AI computer models analyze humidity and wind shear patterns hours before clouds form. These advances expanded average lead warning times from 0 to 15 critical minutes. Those 15 minutes save thousands of human lives every single year. Yet despite supercomputers and radar, we remain completely unable to stop a tornado. We can only observe from a safe distance as nature exerts its raw kinetic energy. The United States isn't targeted out of malice. It is simply trapped in geography, a collision zone sculpted by mountains, oceans, and global wind currents over millions of years. If you found this journey into weather physics fascinating, hit the like button. Share your thoughts in the comments below. What global mystery should we decode next? Subscribe to Inquiro for more deep dives into how our world works. Curiosity starts here. Thank you for watching.